Another segment in it. I'm going to give Harold a call now and see what he's got to say. Hello, Mr. Harold.
Hi, Mr. Ray.
It's Ray Luff calling.
Right?
It's Ray Luff calling from Truth is What Matters.
Ah, very good.
And have you live on the air right now.
Oh, really?
And we actually found a way to put it out public so that you might actually be being listened to immediately on the air.
Oh, okay, very
I
good.
understand you have some friends with you right now.
That's right, yeah. We're Chuck and Cheryl and George and Lois, yeah.
Okay. We've been doing a session with Adam, asking him about his beliefs and asking him whether he was a good person or not, and going through some 10 Commandments to find out. We were asking that of Brad as well, but that was kind of just, that wasn't really the topic of evolution, but we've decided we're going to have that discussion on our next time we get together with Adam, and that now we're going to switch over to just a small chat on evolution. Now, Adam first got in touch with us, and by the way, I'm missing Brad now. He had to go home because we were running late. We had all kinds of technical difficulties today. But you put on a program with me about almost a year ago now, back in August, I think it was.
Yeah.
And that's when we first met Adam, because he gave some response to that program. And since that time, we've discussed having him come on the program to be able to talk to you directly. Now, I asked Adam, who's on the line here now, do you recall that program? Any specific questions from that program you'd like to ask Harold right now?
That's right. No, I've looked at what I originally said about the original show itself, and you're talking about a series of fossils, possible fossils of human ancestors back from the early part of the 20th century. And some of these were obvious hoaxes, like Piltdown Man. There was a case of mistaken identity. Like you also brought up Nebraska Man, which turned out to be a pig tooth in the end. And then there was the Java Man, which I think you claimed was a gibbon in the end, but it's actually the skull cap of Homo erectus, one of the early members of kind of our group. But all of these fossils are from like the end of the 19th or the start of the 20th century. And I just wondered how much you know about kind of the later fossils that we found since then. Like you've got your Lucy, you've got your Neanderthals, all the kind of more recent discoveries.
The Neanderthals, very interesting. There's a book written, I wish I could remember the exact name, but by a forensic dentist, and he showed quite clearly from his research as a dentist that the Neanderthals were actually the same as modern man, basically. In fact, recent documentaries I've watched on TV agree with that they have the same genes basically as modern man. In fact, a lot of their genes are still found through sprinklings all over the world, in Central Europe, and China, and some in North America. So they weren't an intermediary species. They were man. They were Homo sapiens.
All right, sorry about the delay. So are you still there, Harold?
Yeah.
Okay, so I'm going to try this again. Sorry, Harold. Could you repeat the answer that you gave to Adam a minute ago? Sorry about that.
Yeah.
And all your guests at your home.
Very good. With respect to the Neanderthals, very interesting. I can't just recall at the moment the name of the exact book, but I have a friend of a friend that has done a lot of research in Neanderthals. He's basically a dentist and has done a lot of forensic work, and he has shown that the Neanderthals, from their skull and jaw and so on, were basically Homo sapiens, same as modern man. And I was just watching a documentary on TV that shows the same thing. They can show that the genes of the Neanderthals are spread around the world today, and peoples all over the world, mainly in Europe, and some in China, some in North America. So Neanderthals were really, I believe, simply Homo sapiens, with a little different mutation perhaps from most of the people today, but the same basic genus.
Okay, did you hear that, Adam?
Yeah, I think I've heard of the book he's referring to before. It's called, I think it's called Buried Alive. And it's a rather famous book. I think it was a dentist who went to France and examined some of the Neanderthal skulls, and by, I think it was applying rates of human growth to them, he came to the conclusion that they were just really old humans. You probably know that the Neanderthals had big, thick brow ridges, and he basically calculated that at the rate that the human brow kind of grows, you could get a Neanderthal-looking brow after about 300 or 400 years or so. And so he ultimately reached the conclusion that they were just, 300 or 400-year-old regular human beings. I think the problem with that book and that kind of line of reasoning was that you get a different result for each thing you measured. Like, our brows and all our different parts of our skull grow at different rates. So if you apply the Neanderthal measurements, take, say, the brow ridge, you get a figure of, say, 300 years. If you measure, say, the size of their nose, because they had a bigger nose than us, you only get a figure of 150. They don't line up. And so it's pretty clear that trying to do this method of applying the human, applying human measurements to Neanderthals just doesn't work. And so that casts a lot of doubt on his conclusions that they are just old people.
I'm sure it could be debated, but I think the basic evidence seems to suggest that they were basically Homo sapiens, same as us. And with regard to Java Man that you were mentioning, Adam, I don't think I've had any problem with the parts of the skull that they found belong to Homo erectus, but the problem was, as was noted by both evolutionists and creationists, that other parts of the bone, the teeth that he tried to put together were from a different species, from gibbons, from monkey-type creatures over in the Java area.
I'm sorry, I didn't hear a word of that. It was very crackly.
Oh, you're still not hearing it that well, Adam?
No.
Did you hear part of it, or do you want to...
I heard a vague reference to Homo erectus, I think, but beyond that, no.
Okay. Try giving me the answer again, Harold. Sorry about that. And next time we do this show this way, I'll have another way of hooking up the phone directly to the computer.
Yes, with regard to, I think Adam spoke on this concerning the dentist. I think his book was called Buried Alive, but it has to do with the research on the jaw and the dental section of the Neanderthal people, and he showed quite clearly, I think, that they were simply Homo sapiens. They were men. They weren't an intermediary species or some kind of creature in between ape man to the cancerous sort of thing. So I think it's fairly clear that they actually were type of modern man. They were like Homo species, not monkey species, not Pithecia.
Yeah, the Neanderthal things are very interesting. I mean, we're getting a lot of kind of genetic evidence nowadays that humans and Neanderthals actually interbred, and the kind of classic definition of what makes a species is whether or not you can interbreed. And so that's suggesting to kind of many scientists that Neanderthals were a subspecies of human. They clearly weren't fully human because of all these anatomical differences, but they weren't fully distinct either. They were a subspecies. They were kind of Homo sapiens neanderthalensis, and would be Homo sapiens sapiens, with two subspecies of the same branch. So in effect, we're kind of cousins rather than a direct ancestry. If you want to go back for the direct ancestor, then you've got other specimens, and that's really what kind of I was angling with the original question of the kind of the more recent stuff that I wanted to hit on, just because since the discovery of Java Man and Piltdown Man, human evolution as a field has made a lot of progress, and I was just wondering how familiar you were with the more recent developments. Like Neanderthal being a subspecies, rather than a direct ancestor.
Not really very up to date with on that information, actually. I think the mass of evidence would indicate, though, on research that there's no evidence of any transmutation of
Well, I mean, I don't mind, trying to start. Let's you might not be up to date, but I volunteer at a local museum, and I have people of all kinds of expertise coming in and looking at the skulls, and I speak to them. So, how about I try and give you a quick little introduction to what's going on currently in the field of paleoanthropology.
I couldn't comment on much in the last 20 years, actually. I haven't done much researching on that. But as far as I know, back when I was delving into it, I could see virtually no evidence of transmutation from one species to another. And that's basically coming back to my point that Dr. Colin Anderson, who is a senior paleontologist at the British Museum of Natural History in London, England, mentioned that he couldn't give one example of a transitional species, and yet he still believes in evolution, but he said he had no evidence. This is the problem that I see.
Well, it sounds like you're starting with you have an even more basic problem with evolution before we even start discussing Neanderthals. So, if we were just to take it back to basics, the way I like to think of evolution is there's kind of two components of the theory of evolution. You've got kind of the car, which is the mechanism of evolution, and then the journey that car has gone on, and that's the last 404.5 billion years of life history. And so the car itself is composed of 3 or 4 really simple things. So I'll just list them off, and you and Ray, if you have a problem with any of these, if you'd like some evidence, feel free to interrupt, and I'll try and explain at that point in a bit more detail. But anyway, the first thing you need for evolution is reproduction with variation. That when you have offspring, the resulting children basically don't look the same as their parents. They're a bit varied. This can happen for a variety of reasons. I mean, if you have sexual reproduction, you get 2 sets of genes going in together and merging together to make a new kind of thing. Also, during sex, things tend to get a lot. Genes will get muddled up and flipped around, and that can introduce variation. Or you can have your kind of classic mutations, which is the one everyone's a bit more familiar with. But so I assume you've seen children in the past, and they don't look the same as their parents.
I'm not familiar with that, Adam.
Yeah, I would say that does fall within the general range of evolution within a species, though. I mean, you get your pigeons, and if you breed them well enough, you'll end up with white pigeons when you started off with gray pigeons. So the variety that happens within a species has always been part of God's plan, as far as I know. But it doesn't prove crossing between species.
Okay, well, yeah, I mean, alone that's normally not enough to result in cross mutation. You just wind up with a bunch of kind of different looking offspring. The second phase is where things start to really kind of kick off, and basically you have the variants, and if they are good at surviving the environment, they'll have more children, and that variation will spread through the population until everyone, is a bit more, every pigeon's a bit whiter or whatever. It happens to be advantageous. If the change is bad, they won't really have any children, and that variation will die out. And so over, several generations, you'll wind up with the kind of change that you just described, right? Where you wind up with, gradually changing over time.
The interesting experiment, and I know I've learned this from Harold in the past, is that if you take white pigeons and leave them on their own, they end up becoming gray pigeons again. It takes the constant effort of continued selective breeding to keep the breed pure. You find that with all the dogs and everything else, they all go back to their wild form again, eh?
Well, that's because, without the influence of man, that kind of more natural form is probably what's advantageous. Right. It's not as though there's some kind of ladder that everything's progressing towards, everything's just adapting to the environment. Yeah. If we come along and say being a dog is advantageous, then you'll get things turning into dogs. But if that's not, then
this is where Harold and I would disagree with you, and I'll let Harold speak for himself in a minute. Because we don't get cats turning into dogs, we just get dogs that, or in the case of pigeons, that change their color and go back to the original color. And when you look at dogs, we get dogs that end up wild eventually with wild characteristics, but we breed all those wild characteristics out of them as long as we keep breeding going on.
Yeah.
Artificially.
Well, that's because when you're not living in a house with a human, being wild is the advantageous thing. That's the thing that will spread.
Right, but we don't get any dog suddenly becoming a cat.
Yeah. I mean, it takes a long time. I mean, just thinking about this, slight variation, like just a slight change in colour, takes so many generations to spread through the population.
Well, I'll let you speak to that yourself, Harold. What do you think, Harold?
Well, as I see it, what Adam seems to be saying, and I'm not getting his him entirely clearly on the phone, but is that you can go from a subspecies to a species, and that would require favorable mutation. As I understand it, there's no example of a favorable mutation leading to a transmutation process. This has never been shown to exist, and yet that's one of the basic foundations of the Darwinian theory of evolution. I know that's old, but still the one that they uphold. So I don't see how you can go from from a subspecies to a species and actually change into a different species or a different genus. As you say, it's equivalent to going from a cat to a dog or a dog to a cat.
Well, yeah. I mean, generally speaking, just the mutations and the natural selection alone typically isn't enough to get you to a separate species. You need the third kind of step on the chain, and that's simply isolation. If you have two populations in two different environments, they might start off the same, but these gradual changes, and then different changes will be selected for in the different environments because what's advantageous in one might not necessarily be advantageous in the other, and you'll wind up with these two different populations kind of gradually splitting as the beneficial changes accumulate through natural selection.
That goes back to the Gould theory of punctuated equilibria. That requires an addition of information, and it requires a favorable mutation, and none of that has ever been demonstrated as far as I know. There's just no mechanism there to show that could take place or ever has taken place.
Well, my internet's dropped down, so I don't have the ideal examples of the classic examples of favorable mutation, but I can tell you some favorable mutations that humans have when you compare them to chimps. We have, for example, one mutation which basically alters how proteins are expressed in our fingers, and that allows us to get a lot more kind of dexterous growth here in your muscles and so on. There's another one I can't remember the name of, but that reduces the size of the muscles on the top of your head, and that basically means there's less constraining the brain, so the brain is free to grow big and large.
Adam, you're stating differences between two different species, an ape and a man. How a man has these muscles in their head and the fingers are more dexterous. But that doesn't prove that the ape became a man. It just proves there are differences between men and apes.
Well, yeah, I mean that's why I don't like to use it, but these are the only ones out of the top of my head. Like I said, the internet's gone. But the thing about these changes is that they're basically the same gene, except for a very slight, these are things that just a single mutate, like a few changes to the DNA will produce these changes. I mean, there are people who live who sometimes will lack these mutations, or they'll have them revert back to the kind of ape state. There's one called the FOXP2 gene, which is involved with producing the muscles you need to speak clearly. And people will have a mutation that basically kind of, they don't have the mutation everyone else has, and they have real trouble doing this, and they kind of go back to kind of the ape state of things.
Isn't that the case where they have a mutation that's a destructive mutation that has caused them that they can't speak properly? Like you're claiming that we have a mutation that's a positive mutation that made us speak properly, but isn't it the opposite?
Well, no, I mean,
an unfavorable mutation?
These things are favourable in different circumstances. Like if you go back to the muscle one I mentioned, on the plus side, the lack of muscles up there means our brain is free to grow big and, powerful. But on the other hand, it means that our jaw is a lot weaker than a chimp's. And so in the chimp's environment, having that strong jaw is beneficial. And so on the one hand, it's a disadvantage, on the other hand, it's an advantage. And that's true with a lot of changes between, two species. It's very difficult to, a lot of changes are, kind of beneficial, kind of detrimental. It's all about the environment, what's beneficial in the environment. There's no absolute standard of what's good. I mean, you go back to the
it's an interesting word you've used, environment, or it's God, because God might have created those differences to make the advantages that you're talking about. However, the missing thing here is how the environment acts like God and causes a positive mutation, like you've been saying. You can say positive benefits for men over apes, or also a positive benefit of an ape over a man, from what you're telling me, right?
Yeah.
But on the other hand, it doesn't prove the mutation between one to the other. It just proves there are positive differences.
When you look at what, I don't really know how to respond to that. It's difficult when I'm coming from a
That's okay.
I had all these resources lined up that
That's okay,
explain better than I could. But I think the point is showing that just basically these changes are so small that it just takes a tiny change to go from a man, from something that looks like a human to something that doesn't, to lose all of these so-called human advantages. It only requires really small changes, and so you can just say that they happen to be coincidental changes. But when you look at how little has to change, it makes it really clear that they're that we are closely related. I mean, there are two species of mouse that are as different from each other as we are from chimps, and they're classified in the same species. They're subspecies of each other.
Harold, I'm just wondering, do you recall, we've had conversations like this in the past, Harold and I, do you recall some of the species that are very close to each other that are quite surprising as far as DNA goes? Like, wasn't a whale very close to a man? So therefore we must have come from a whale. But on the other hand, that a flea was very close in DNA to a whale as well. So a whale must have come from a flea. Remember that booklet that we had that we published with ICC? It had examples like that in it.
Okay, I'll come.
But, sorry, go ahead, Harold.
No, I can't recall the detail on that.
Yeah. What I suggest is that we're going to do a later program, because we've used up the amount of time we said we'd use in calling you, Harold.
Okay.
Another week. That's okay, and we've taken your guests a long time.
No, that's very interesting information that he's presenting. I think the basic point, it really is, though, that you can have favorable mutations in the sense that, again, as Adam, I think, is suggesting, that there's an adaptation to the environment. And I think what it all boils down to in the long run, though, is a mutation, as you're saying, Ray, within a species rather than a change from one species to another, or from a subspecies to a full species. Because as I understand it, there's never been an example of any added information to the genes ever being shown to have taken place, and that's what would be required. And then that, if you have that, then you can have not just mutation, which can be really quite radical and quite amazing, but you would have transmutation. That would provide evidence for evolution and change from one species to another, and from elevation from one species to another. That's what I think is being talked about. Anyway, it was really good to be online, and thanks very much for the opportunity, Ray and Adam, and to talk to you.
Enjoy your meal, Harold.
Okay, thanks a lot. Bye,
We'll get together another week.
Bye, Ray.
All right, God bless.
Bye.
All right. Sorry. We'll have another week. So what you should do is some homework on what you were talking about. We'll bring it up again. So on the newer examples. Now, just give Harold some slack. Harold's 80 years old. He is retired.
Yeah, I mean, I was trying to go from the kind of the starting point, and the idea is that you just have these three steps, and that's just the car of evolution.
Yeah.
And that's the kind of mechanism, and then it goes, and then over 4.5 billion years, that mechanism has caused things to change, and that's kind of all that's really to evolution. People try and draw this distinction between micro and macro evolution, but for this car to drive a little bit, and for it to drive a long way, you don't need anything else. There's no extra mechanism to get macroevolution. All you need is more time. There's no magical thing that we haven't seen in day-to-day life that you need for speciation. I mean, we've observed speciation events. One of my favourite examples is there's mosquitoes in the London Underground, and they're a different species to their surface-dwelling counterparts. So, when the London Underground first opened about 100 years ago, a population went down there, became isolated, and speciated them. So now you've got, where there was one species of mosquito in London, you've now got two.
Okay, well actually, probably Harold and I would say there's still mosquitoes, so you've got an evolution within a species again. The reason we're so big on this. The reason we're so big on evolution within a species is because the Bible says that God made everything after its kind. And I think the word kind relates to the word species in today's language, so that each kind seems to have a barrier between it according to our understanding of what we read in Genesis. But
well, the problem with looking at it like that is that basically you can group all the mosquitoes together as a kind, but the mosquito is kind of a family, and so if you use the same definition of to group all the mosquitoes together, we'd be grouped with chimps. And it's basically because the difference between us and a chimp is we're different at one kind of taxonomic level, and it's hard to explain without a kind of a diagram. But basically, taxonomy basically works by having kind of nested hierarchies, where there's our family and then there's a chimp family, and we make, I think it's a sub-family, and then you have a family, and then that two sub-families make a family together, and so on and so on. It's kind of nested hierarchies.
yeah.
And the level that you're grouping mosquitoes together at would include, if you did that same definition on us, we'd fall within the chimp group. We'd fall within the chimp kind if you defined it like that.
I understand your argument. I've read something on this, and it's not recent, but it was about a 97% similarity between humans and chimps. But the problem was the 3% difference is as much difference as there is between whole species of other species. So it's something that we should think about and come back with some more actual information for a further show. Because right now we're kind of clutching at facts that are soft facts.
I'll try.
Plus we lost one of our experts from being online with us now. So.
But yeah, I mean there was one creationist. And he did this kind of have you ever heard of, I think it's baraminology or something like that, which is what they use to define kinds, and he did this analysis on humans on the Australopiths, like Lucy, and he found that if you use the definition of kind that creationists normally use to group together all the dogs or all the mosquitoes or whatever, we'd be grouped with the ape-like, kind of our ape-like ancestors, would be grouped as the same kind. And so under that model, creationists would accept human evolution, albeit on a much shorter timescale. We'd fall within the kind of chimp and the Australopith kind together. And so it's a bit of, I think, kind of special pleading to argue for one definition in this circumstances and a different definition.
When you mentioned Lucy, it's still a debate whether Lucy's an ape or a human in the first place.
She's what we call a hominin, which is the word for
human.
Basically, basically a transitional form. She's got a lot of ape-like traits. She's got the face that sticks out. She's got long arms that climb through the trees, long curved fingers. But at the same time, she was bipedal. She had teeth that were more human-like and a mouth that was more human-like. So she's kind of that mixture of traits you'd expect to see in a transitional kind of form.
Well, you mentioned bipedal. Like the feet are different than on an ape. It still is a debate whether you're talking about a deformed human, which lots of deformed humans exist. There are hunchback people in the world, and there's different types of deformities people have. So it's still a bit of a debate about whether we've just found a deformed human being.
There's no set of diseases that's ever been documented that will result in some kind of criteria that you use for that define Lucy's species, and we found loads of her. There's several, I think, it might be on for over a dozen, maybe even over 50 examples of her species. And so the odds of that all be, just having one population of deformed individuals.
You bring up something. They found part of Lucy a mile away from another part of Lucy, which no one can explain why they're finding it so far away apart.
That was another piece of that was another member of her species. That they found far away, and so they say, look, we found it was another important before Lucy. That other find was the most significant one.
I guess what I was being told was that they put together Lucy with parts that are as far away as a mile away from where they found the one part.
Yeah.
So
Well, yeah. In the press conference, the scientists were asked how far away from this earlier find did you find Lucy, and they said, "Oh, it's a mile away," and that kind of got misheard and turned into we found a bit of her a mile away when it was really she's just a mile away from another Lucy.
I'm not claiming to be the expert on that topic, and I haven't done.
Neither am I. This is from memory, so I'm going to have to look this up again later and check.
So,
but as I recall, all of Lucy was kind of found together. And there are other examples of members of her species elsewhere, but they're not classed as Lucy. Lucy is this one individual from this one site.
Okay.
She's only 47% complete though, so there is still some mystery about her. I mean, I can't claim to have the final say on it.
Yeah.
All I can claim to say is the best answer we have at the moment is that she fell in the middle here.
Yeah. Okay, so I'm going to wrap up the show, and I'm probably going to take some sound bites out. I won't keep it all because this is a lot longer than we normally do a show we've done today, with lots of technical difficulties and whatnot.
Yeah, well, hopefully when you get them ironed out, we can have something that's a little easier
and so
to deal with.
We'll try again. We'll have another follow-up show possibly within a month. I'm going to try to get another setup where we're going live on Ustream by then. Because I'm getting something called a VidEU, which is a way of going live with the camera, with the main camera, straight to the internet. Yeah. So thanks a lot for coming on the air, Adam. And,
I hope you enjoyed it.
Really appreciate that we've gotten this far, and I'll see what I can cobble together of what the show actually ends up looking like afterwards from the bits and pieces of some of it's been put out on Google, some of it's on our cameras.
Okay.
And this is a real learning experience way that we put this show together this week. Like we're trying to get into new technologies, so we'll find out how we've cobbled all these technologies together, and hopefully it'll be even better in our next show.
Okay.
Thanks a lot, Adam. All right, bye for now. That concludes Truth is What Matters. We've had a very shifting cast tonight with Brad leaving partway through and Harold on for a few minutes, and we've been trying new technologies, and we're hoping to get a little bit more smoother with the new moves to our new technologies in our next program. Thank you.